Good evening, fifth graders. Tonight we're going to be working a little more with some fractions. We're going to be identifying the whole. That means we're going to be working a little bit with the denominator as well as the numerator. Once again, remember, whatever you multiply on the bottom, you multiply on the top. Whatever you divide on the bottom, you divide on the top, and vice versa, okay? Just make sure you're doing the same thing on the top and the bottom. Here's some problems we're going to be working with for some practice today. If I have 5 counters, which is 1/10 of the set, what is my whole? So that means the 5 is the numerator. So I have 1/10, which equals 5 as my numerator. I want to find the whole. 1 times 5 is 5. 10 times 5 is 50. 50 is my answer. That is my whole. Let's keep going. If 8 counters are half the set, what is the whole? Well, we have half the set, which is 8 counters. I want to find my whole. 1 times 8, 2 times 8 equals 16. 16 is my answer there. A set has 40 counters. How many counters are in 3/8 of the set? What is the whole? Okay. So if a set has 40 counters, how many counters are 3/8 of the set? So 40 is my number. I want to find 3/8. 40 is my denominator, right? That's what the set is. 8 times 5, 3 times 5 would be 15. So 3/8 would equal 15. If 20 counters are 2/10 of the set, what is the whole? So I have 2/10. 20 counters is 2/10. I want to know what the whole set is. That means my 20 is my numerator, right, kids? I'm trying to find out what the whole set is. 2 times 10, that means 10 times 10, which equals 100. A set has 25 counters. How many counters are in 4/5 of the set? 4/5 is what percent of the set? So the set has 25 counters. How many counters are 4/5? So if there's 4/5, 25 is the set, right, kids? So I have the 25 as my denominator. I'm going times 5. I'm going times 5. That equals 20. They want to know what is 4/5 as a percent. Remember the hearts we worked on earlier on with the 10, with the 100, with the 1,000 in it? Okay, that's what we have to work here. We have to put the 5 into a 10. Putting a 10 here, times 2 gives us 8. 8/10. I have to add a 0 here, which would be 80%. This is all review, I hope. Okay, let's keep on going back here. If 12 counters are 2/3 of the set, what is the whole? So 12 would be my numerator. So 2/3 would be 12, right? I want to find out how big the set is, which is my whole, which would be my denominator. 2 times 6, 3 times 6 equals 18. That is my whole. Now we're going to kind of jump ahead here since I showed all my work here to a few problems that you might come across tonight, or tomorrow I should say, okay? Lamont, Jose, and Kenji are recycling soda cans. Lamont collects 13 cans, Jose collects 20 cans, and Kenji collects 17 cans. What percent of the cans does Jose collect? Okay, unit, we're dealing with cans, right? What is my whole? I want to know what percent the cans Jose collects. Jose collects 20 cans, right? So I have 20 for Jose, but I want to know what is my denominator. What is my total here? So I'm going to have to add 13 plus 17 plus 20. Because those are all the cans put together, right? Gives me 50. So that means 50 is my fraction. 50 is my whole. What's my percent? I have a calculator here, but I don't even have to use the calculator because 20 over 50, just going back to my heart problems, right? I'm putting this into 100 times 2 times 2 gives me 40 over 100, which would be 0.40, which would be 40%. Let's look at another problem here. Jackie and Edna decided to share their hot lunches. They put together their fried potatoes and their onion rings. There are 33 pieces of fried potatoes and 17 onion rings. What percent of the lunches are the onion rings? Okay, so unit, we're going to be dealing with food. Okay. Actually, I wouldn't say food. I would have to say onion rings, right? Food. Must be hungry. Onion rings, right? We want to know what percent are onion rings. What would be my total? Well, I'd have to add 13 plus 17 up. Gives me 50, so that's my whole. I want to know what percent of lunches are onion rings. Onion rings are 17, so my fraction would be 17 over 50, because that's my total. I don't need a calculator for this, because I know 50 can go into 100. I'm going times 2. I'm going times 2. Gives me 34, which would be 0.34, which would be 34% for an answer. Onion rings. That looks like a 37. There's a better 34. Okay, let's keep going. The boys club is having a popcorn sale. Each of the 10 members of the club is given 5 boxes. So every person has 5 boxes of popcorn. Edward, so he's one of the people in the club, sells only 3. What percent of the 5 boxes remain for Edward to sell? So Edward, I have to just write this down because it's a lot of words, a lot of numbers. I don't think all these numbers are important. Edward, let's see here. He starts with 5 boxes, right? He sells 3 of them. So he has 2 left. Okay, that's basic math there, okay? What percent of the 5 boxes remain for Edward to sell? Okay, my unit is boxes. My whole, Edward starts with 5 boxes, right? How many does he have left to sell? He has 2/5 left to sell. What's the percent? I have 2/5 that go into 10, right? Times 2 gives me 4. This would look like 0.4. I'd add a 0 there, which would give me 40%. Keep this in mind. They try to throw you off with the 10 members. Not important, right? When you're doing these things and I ask you to take out your scratch paper, please take out your scratch paper in class. Really focus in on what the question's asking. So a lot of times when you raise your hand and you're wondering, Mr. Dean, can you come help me? I'm not going to read the question to you if it's something I know you're capable of doing this. So I want you to take your time tomorrow. If you're ready to solve these problems, always ask, is this number going to be the numerator I'm trying to find or the denominator I'm trying to find? Hope this helps. I look forward to working with identifying the whole with you in class tomorrow.